Good afternoon, good morning, depending on where you are calling in from. We'd like to thank you very much for joining us today. And today we are happy to tell you about how OpenTopography has made the open USGS 3D elevation program datasets discoverable along with processing options through our site, currently to US academics. There are 3 hosts to this webinar today. My name is Chelsea Scott. I work at Arizona State University, where I'm a research scientist and a co-investigator for OpenTopography. Matt Beckley is a data engineer at UNAVCO in Boulder, Colorado, and he's done a lot of the day-to-day hard work of making these data sets accessible through OpenTopography. And Chris Crosby is a project manager and co-PI for OpenTopography, also at UNAVCO. And we'd like to thank Melissa Weber at UNAVCO, who's done a lot of, helped us a lot to put together the webinar from a technical side. So our agenda for today, we will begin with an overview of OpenTopography in general, discussing some of the functionality, our motivation. Then we'll discuss the implementation, or how we've made the USGS 3D elevation data available through OpenTopography. Matt Beckley will lead us through a demo of how US academics can access the 3D data sets through OpenTopography. We'll have a section towards the end for final comments. We've left about 15 minutes towards the end for questions. But we do invite you to ask questions throughout the webinar. Please use the Q&A window at the bottom. We'll answer some of them through chat. Some we may stop the webinar to answer, and then the remaining questions we'll hold for the end. So thank you. And Chris.
Oops. Great, thank you, Chelsea. Yeah, thanks for everybody for joining us. Looks like people are still actually trickling in, but so this webinar is really an opportunity for us to promote or demonstrate this new USGS 3D functionality, but it's also sort of a chance for us to give many of you sort of a refresher on what it is OpenTopography does. And some of you, I'm looking at the registration list, I know are very familiar with OpenTopography. Some of you may be less so. So we're gonna do some overview, and then you'll see this demo that Matt will do, where hopefully it should seem very familiar to many of you. That's one of the powers of this whole thing, is that if you're used to using OpenTopography, the new 3D data will be very familiar. But it's also a chance for us just to remind you of some of the things that OpenTopography can do with lidar point cloud data. So just a quick reminder of who OpenTopography is. This is the team in the upper left. You've met 3 of us right now on this webinar, but other participants include Vishu Nandigam, who's the PI of OpenTopography at San Diego Supercomputer Center. Vishu's lurking somewhere on the webinar. Min Fan is also at SDSC, is one of the software engineers who does a lot of the user interface and back-end work. And then Ramon Aerosmith, who's a co-PI at Arizona State. So this is a project that's a collaboration between the San Diego Supercomputer Center, UNAVCO, and Arizona State University. And this is a project that received its first round of funding from the National Science Foundation in 2009, but has been sort of in the works. Some of the thinking about LiDAR in a web-based environment goes back to 2004. And importantly, this is a project that's supported by the National Science Foundation Division of Earth Sciences, and specifically the Geoinformatics program. And so this will become important later when we talk a little bit more about this academic user restriction that we presently have applied to these data. So OpenTopo is really about making LiDAR data and other topographic data products easy to use and access, and sort of allowing people to access the data at the kind of level at which they want to be able to work with it. So this is everything from raw point cloud data sets through to relatively easy to use visualizations, whether those are web-based or Google Earth-based types of interactivity. And so back when we started this project, we were really trying to make it easy for Earth scientists who didn't have experience with LiDAR point cloud data, didn't have necessarily have access to specific software packages, to be able to pull out the type of product they wanted to bring into their GIS environment, or even like print out onto a piece of paper and take out in the field to map on top of. And so there's this multi-tiered access to the data, and you'll see this in the demo when Matt runs through that. There's a kind of classic web map interface that you can make an area of interest selection. That's what Matt's going to demo today. We also provide bulk download of the data sets that we're currently hosting. And we have a growing suite of APIs and sort of web services for accessing some of the data. For example, you can get global topography like SRTM through a simple RESTful command line interface web service that OpenTopography provides. So this is what the OpenTopography catalog looks like if you look at the data sets that are hosted at the San Diego Supercomputer Center on our machines. So it's 342 data sets. It's like 1.6 trillion LiDAR points. So it's all the red polygons. We have a growing amount of data in New Zealand because we've got a partnership with Land Information New Zealand to provide access to their point cloud. So OpenTopography is the official distribution pathway for the nationwide LINS LiDAR effort. And that's a multi-year, it's going to be another, I think, 5 years before they get to national coverage. And all that data comes through OpenTopography. The red polygons that you see in the US map are largely collected for Earth science research purposes. So these are data sets collected by groups like NCALM, either for specific PI-driven research projects. A lot of these data sets are for graduate students, so they get collected through the NCALM Seed project. And then we have a few other partnerships with larger agencies. So back in the early 2010s, we worked with the state of Indiana to provide hosting and distribution for their whole point cloud. So that's what OpenTopo looks like today. And one of the criticisms of OpenTopography has always been, well, it's great, it's easy to use, but the map is pretty sparse, really. Like if you're a user in lots of parts of the United States, you can't access the data. You can't get to data that is in your area of interest. And so the USGS 3DEP program is this really exciting opportunity here. So this is a map that I've grabbed from the USGS. It shows the current state of the USGS 3DEP program in FY20. So the goal of 3DEP is to provide essentially nationwide high-resolution topographic coverage with LiDAR using IFSAR in Alaska by 2023. And the idea is that this is a data set that has like less than a decade time frame. So it's basically in theory would be refreshed every decade. This represents a massive investment of spending. So tens to over $100 million per year has been invested in the collection of these data sets. It's a cost share model. So the federal government, USGS, contributes a significant chunk, but then state, local partners bring additional money to the table to collect these data. So what's shown in the frame here, or shown here, is the dark green are data sets that have been collected. FY20 are data sets that are basically either in process or will be collected and will eventually become available. So this is the data set that we're talking about exposing through OpenTopography. And it's really exciting because it suddenly fills in the map, right? It covers a good chunk of the United States and at a very high quality data. So what happened is that in February of 2019, the USGS, in partnership with Howard Butler and some others, Amazon, worked together to basically migrate the LiDAR point cloud and some of the other products into the Amazon environment, Amazon Web Services. And so there's actually two buckets of data in Amazon. One is a bucket full of LAZ point cloud files. So for those of you that work with LiDAR point cloud data, you may be familiar with this format. It's a compressed LAS. And then there's another bucket that is this entwine point tile format, which is a optimized octree that sits on top of the LAZ compressed files, basically, and allows sort of high performance streaming and browsing of these data. And these two buckets are sitting in Amazon. One is a requester's pay bucket, which means that to get data out of it, you pay for the egress charges. You pay Amazon for the egress charges. The other data set is this entwine one, and it's sitting inside the Amazon public data set space. So this means that this data set is free to access and free to egress data out of. And so that's really quite exciting because it means that all of us can reach in and pull this data out, write software and interact with it without paying the cost of egressing the data. So moving on, what we've done in the last, so we basically released this in February of 2020. We leveraged this infrastructure that the USGS and Howard Butler's company Hobu has put together to leverage that Amazon public data set and really allow you to route access to those data sets through OpenTopography and then apply our kind of value added processing services on top of all that data. So the idea here is that suddenly the map has got a lot of green on it, which is the USGS 3DEP data, and all of those data sets you can use existing OpenTopo functionality to clip the data sets out, process them, produce derivatives, produce visualizations, and download them as you would with any of the data sets that are hosted at SDSC, like the ones in red in this map. And the goal really here is to make it easier for the academic research community, educators to access the data and to derive new science and interesting impacts from this relatively massive investment in the collection of the data initially. So a cartoon of how this works, and then Matt's going to show it to you in real world, but basically you interact with OpenTopo through the browser. Those machines are in San Diego at the San Diego Supercomputer Center. When you make a selection on one of the 3DEP data sets, we go out to the Amazon resource and we extract the clipped piece of data that we need, we bring it back, and then we pass it through the existing OpenTopo processing tools. So these are the things that allow you to produce derivatives like DEMs and DTMs, DSMs in various file formats to create visualizations, both a raster and point cloud-based visualizations. So this whole workflow is essentially happening, all the processing happening at OpenTopography in San Diego, but the data access is happening from this Amazon public data set resource. You can also do things like do hydrologic analysis of terrain data. So this is a tool that's already in OpenTopo. This is the Tau DEM tool. It does hydraulic routing. It's a little bit like ArcHydro for those of you who are familiar with that tool set. This is available for 3DEP. The other thing that we've spent a lot of time in the last, say, year and a half on is tools for doing intercomparison of data sets, so topographic differencing, and Chelsea's been the lead on a lot of this work. So we have vertical differencing tools to just do change in the Z direction, but we also have full kind of ICP 3D point cloud change detection. And our goal here in the future is to enable those tools on the 3DEP data. So at the moment, you can't topographically difference against 3DEP, but that's something that's in the works, so coming soon, hopefully. So here's the present status of what's in OpenTopography and then some caveats. And we'll talk a little bit more about the caveats here in a second. But so there's something like 1,434 3DEP data sets. So that's individual, basically green polygons of data. It's by our count, 25 trillion lidar points. So this is exciting. So this is like, we told you OpenTopo is hosting 1.6, but now a trillion points. So suddenly we've got 25 additional trillion points basically overnight by unlocking this functionality. So this is very powerful. Right now, we have this academic user restriction. So basically to get the data, you have to have a .edu account, which would be in your US academic. So there's 863 of you have unlocked this functionality. Basically, you've clicked the button that says allow me to process 3DEP data, and there's been 2,271 jobs run. So some caveats about this. This is still an early phase project. We're considering this a pilot. And so just the other day, we increased processing limits to 250 million points per job. It was previously set at 150 million points per job. So we're just sort of testing the waters to see how this scales and performs. Importantly, runtimes on this functionality are longer. So if you're used to running a job in OpenTopography, say you go pull 50 or 100 million points, that job might run in tens of seconds to maybe hundreds of seconds. There is a network transfer that happens in this implementation of 3DEP. So we're going across the network from San Diego to, I think it's US West Zone Amazon, to pluck the data set and bring it back. And so that definitely imparts an additional runtime. So jobs are running in hundreds to thousands of seconds. And so that's worth knowing. And so this is in part why we're being a little cautious with our kind of processing limits. Another subtlety here is that this is not a resource that we have control over. So we don't have any ability to say when data get published there. And so this is basically the USGS is currently populating that. And so the data appear there. And so we've had some questions from users who say, why is this data set not available yet? Or I see it in one place but not in another USGS access pathway. Those are all issues that are sort of beyond our control. Similarly, issues about availability of metadata and other things are also not something that we have a lot of leverage over. And most importantly, is from looking at registrations, we know that most of you on this webinar are coming from a US academic institution, but some of you are not. And so we've currently limited this to this US academic community because that's who NSF fundamentally supports us to assist, to provide, to facilitate science and education. And so while we're piloting this process and testing the waters with its performance and evaluating demand, we've made this limitation. Why, you might say, why not just open it up and like let people loose on it? And we'd love to, but we know from some of these large scale data sets, a good example being the Indiana statewide lidar that OpenTopo has been hosting now for approaching 8 years, that large data sets with lots of spatial extent that cover lots of different kinds of places tend to drive lots of utilization. And at the moment, although the access to the data is free, thanks to Amazon, the compute to derive custom products from that data is not free. And we have infrastructure in place that we feel supports our current user community, but we're not resourced at the level necessary to provide on-demand computation against 25 trillion LiDAR points to anybody who walks in the door. That's just the reality. This is what NSF supports us to do, is not necessarily deliver all of these data for free to every single user out there. And so this is something we're working on. And currently, as I said, we're treating this as a pilot. So we're evaluating the performance and scalability. We're also evaluating demand for this service. Like how many people out there really would like to be able to get these data through OpenTopography versus the other pathways through which you can get this data. Like basically how important is that value added service that sits on top of the data, because the data anybody can get for free at any time. And so this is an ongoing conversation with the National Science Foundation about how to do this and how to do it in a way that honors the core mandate of NSF's funding to OpenTopography. And it's also part of a broader conversation about OpenTopography as an entity that is perhaps sustainable beyond funding from just the National Science Foundation. So this is an ongoing discussion that at the moment, we don't have a great update on, but we're happy to answer questions and also happy to entertain ideas about how to make this work at scale for basically everybody, because we'd really like to be able to do this as a free service to the broader community, whether they're academics or practitioners or government agencies or whatever. But at the moment, it's still in the works. And anything that we do basically has to be blessed by the National Science Foundation because they're funding the core infrastructure. So that's part of that is why this is a conversation and a negotiation that is ongoing and is subject a little bit to the bureaucracy of NSF. So for now, I'm going to hand off to Matt, and Matt's going to run through a demo of how this actually works in practice and show you some tips and tricks and other things. And then we'll come back for a couple other wrap-up slides and Q&A. So I'm going to stop sharing. Matt, all you.
Okay. Can you guys see my screen? Okay.
Yes, looks good, Matt.
Okay.
And I guess, Matt, I just would say that I think, Chelsea, you just pasted the URL in the chat. Is that right?
Yes.
Okay.
Okay, so I'm just going to go through a typical workflow of how you can access the 3Dep data through OpenTopography. And this workflow is going to be very familiar to some of you, but we do have a fair amount of people online who are not super familiar with OpenTopo, so I'm hoping this will be useful to them. The 3Dep data set's a little bit different, so I'll try and highlight some of the unique features of it as we go through the workflow. Most people, there's basically two ways where you can get the 3Dep data. You can either go from this data tab, you can go to the data catalog or the find data map. If you go to the data catalog, if you go under the USGS 3Dep tab, you'll see a listing of the data alphabetically. So if you know the name of the data set, or you can filter by state, That's one way of getting it. But the majority of our users will get the data through the Find Data map. And so, as Chris mentioned, the data is in green here. As you zoom in, you'll see the spatial extent of the polygons. And for this tutorial, I'm going to use the Washington Mall as an example. So if we zoom in and select that area, underneath the map, it'll highlight which data sets intersected that area of interest. And just as a quick note, you can sort of see a snapshot of metadata by clicking on the link. And we've scraped some metadata from the USGS XML, so you can get things like survey date, survey area, total points. Another feature I want to highlight that not many people know about is as OT has gotten more data sets, certain areas will be very cluttered and it's hard to see which data sets cover which area. So you can often click this little pin here and it'll sort of highlight the coverage of just that data set. So you can see this, in this case, this covers, I want to look at the Washington Monument, so you can see that this data set covers that. So I'm going to select that data set to examine. And to do that, you just click on the Get Data button. So this will take you to what we consider the landing page for a data set. And for the 3-depth data, most of the landing pages will be very similar. In the overview, we try to give some updates about the 3-depth program and the Amazon Entwine bucket that Howard Butler and his team put together. And we provide some links there that you can get some more detailed information about those projects. We also provide just some basic metadata about each particular data set within the 3-depth. So this metadata pertains to this Maryland, Virginia data set. And we give things like the total number of points, survey area, a rough estimate of point density. And then we also scrape some metadata such as like the survey date, which would be really interesting to a lot of people, as well as when the data was published. We also link to this full metadata link here. Will take you to the USGS resources that have the XMLs for all of the last files. So if you need a deeper dive into the metadata, you can get it that way. And we also link to Howard's usgs.entwine.io site. And this site is run by Howard and his team at Hobu. And here we'll see, basically this is showing all of the resources that are in that Entwine-based public Amazon bucket. So here you can see what data is being processed. You can also click on these links and get a visualization of those data sets using a tool called Poetry that I'll talk about a little later. So once again, your area of interest is highlighted in the map. You can search by, you can change to a satellite view if it happens to be like a feature that you're interested in. In this case, I want the Washington Monument. Another feature I would just want to highlight that many people aren't aware of is the heat map. So if you select on the heat map, you'll see areas where other users are downloading data. So this shows, obviously for this tutorial, I've done some searches over Washington Monument, but other people have searched. You could see over Lincoln Memorial, Jefferson Memorial, White House, Capitol. This feature is really nice for especially people who are doing flight collects or planning any kind of data collection, because they can use this as a metric as to where people are really downloading the data and maybe prioritize those areas for data recollection. So once again, I'm going to zoom in over the Washington Monument. And then I'm just going to step through each of the parameters here and just highlight basically what goes into downloading this data set. As I mentioned, Howard and his team, they really did a lot of the heavy lifting of sort of standardizing this data set. So they took all of the LAS formatted data and put it into an Entwine format. And as part of that, they also reprojected the horizontal coordinate system to all be in Web Mercator. And this is a very common projection for web mapping applications. However, for analysis, it's not really the best projection to use because it can have a lot of distortions in area, especially if the data set is far away from the equator. So what we did as part of including this in OpenTopo is we calculated what the local UTM zone is for each data set. And so we provide that as an output option as one of the projections. So you can see here, you can output in either UTM zone 18 in either the NAD 83 based ellipsoid or the WGS 84 ellipsoid. And naturally, you can still output in the native Web Mercator or in a WGS 84 lat-long coordinate system. But if you want to do any kind of gridding, you need to use the projected UTM zones. We could also we're set up where we probably could expand this to do any kind of projection on the output. But for right now, we find most users are content with a UTM projection. We've also harvested some metadata. So we've pulled out the vertical datums. Most of the time this is nav D88, but sometimes it might be something else. So we've reported what those values are for the vertical datum. We've also harvested all of the classifications per data set. And at the current time, we're not including that, but in the future, we could potentially list out all of the classifications and users can filter by classification. Currently, we enable users to classify by grounds. So users can select this box and essentially get a digital terrain model. So that would only pull out points that are classified as ground. You can also exclude noise, which would basically remove any data that's been classified as noise. So the next step is just your output formats. So most people are familiar with LAS. And as Chris mentioned, LAZ is just simply a compressed form of the LAS point cloud format. We set it as default because the compression ratio is really quite amazing. And so this will help speed up the download of your data, as well as use less disk space. So it's we really recommend that you use the LAZ format when running a job. The next two stages, 2A and 2B, deal with gridding of the data. And so this is where OpenTopo starts to shine in the sense that it's doing a lot of the heavy lifting in the background of creating derivative products. The first method is using the TIN method, triangulated irregular network. Most people are probably familiar with that. And I won't go into the details of how TINs are created. But I will highlight for most of our processes and parameters, we try to put little tooltips. That's that eye in the circle. And so you can get a little more detail about what the algorithm does, how it works, or what any particular parameter does. So it'll give you a little guidance into how to set those. So this section 2A is creating a triangulated irregular network grid. You can set the output resolution. You can also control how big the triangles are. If data is particularly sparse, you may want to set it to not flag an elevation there and maybe flag it as undefined. So you can control that with the triangle sizes. The default output is GeoTIFF, but you can also output as ERDAS Imagine or as Esri's ARC ASCII grid format for any kind of Esri products that you may want to use. The second gridding method we term local gridding. Basically, it's also creating an output raster. It's gridding up this irregular point cloud that you've selected, and you can specify whatever grid resolution you want. And then at each grid cell, we're applying a search radius. And so then within that search radius, we're running statistics on any points that fall within that radius. And you can select which parameters you want to see. So on the left hand, you'll see the options that you can choose. You can choose to report the minimum value that's within that radius, the maximum, the mean, the inverse distance weighted, the standard deviation, the point count, or you can just return all of them and have it layered in a single image. And you can obviously control the size of your output grid. You can also control the size of that search radius. So if you have data that might be sparse, you may want to increase that radius so that you capture enough data to run meaningful statistics. If you want to, we do have a null filling option. Again, if you have sparse data, you can run what we call a sort of a roving window. So for each grid cell that's undefined, you can search an average data over the 3x3, 5x5, or 7x7 cells. So it'll take those surrounding cells, average a value, and then apply it to the undefined value. And then once again, you have GeoTIFF as an output option because that's kind of the most common. A lot of software can read it, but you can also output an ERDAS Imagine or an NV formatted raster. Moving on to derivative products. This will create hillshades and slope grids, but I should note that it will only run if you have selected a grid of within 2A or 2B. So it won't run directly on the point cloud. So you need to select a grid from either 2A or 2B or both, and it'll create a hillshade and slope grid based on those grids. And again, you can output in GeoTIFF or ERDAS Imagine. The next step is sort of a newest feature. So if you haven't used OT in a while, this might be new to you. It's the 3D point cloud visualization. This uses a sort of browser-based web visualization called Poetry that was designed by Marcus Schutz. If you select this box, when the job runs, you'll get an email and it'll have a link. And you click on that link and it'll open this web browser. And the nice thing is you don't need any other software. You could just view it all in the web browser. And I'll give you just a quick look as to what it looks like. So this is my job of the Washington Monument in 3D, plotting the points in this Poetry web viewer. And you can do a whole lot of things with it. I won't go into all of it, but if you click on the hamburger icon in the upper left, you'll see a menu pops out on the left-hand side with a lot more options. And you can do things like not only plot the elevation, but you can plot intensity or classification. If your data set has RGB values, you can plot by RGB. You can filter by classification and by return number. So there's a whole lot of things you can do. One nice thing you could do that I want to highlight is you can do some just basic measurements, which is kind of cool. So we can measure the height of the Washington Monument if we click on the little height tool. And then you could just click at the base and at the top, and it'll calculate the height of the Washington Monument at 168 meters. So you can measure areas and other things. Like I said, I won't go into all of it, but I would really encourage users to check this feature and really play with this tool because there's a lot you can do, and it's a really nice way of interrogating your data set. So that's what you would see if you check that box. You'd gain access to that web viewer, and it's nice because it's localized to your selection that you chose. The next section 4B is for a visualization of data, and this is more creating like static images, PNGs of the hillshades, as well as Google Earth files. And this is a nice feature in the sense that some people just want a nice graphic to use in a report or a proposal. And so if you select this, you'll get a grayscale hillshade PNG. You can also get a color-based PNG of the hillshade, or you can get a Google Earth version of those DEMs and then pull it into Google Earth and orient it how you want and make an image that way. And lastly, Chris spoke about Tau DEM and mentioned it. So here's the options that you have. It's an open source program. It's very similar to Esri's Arc Hydro tools if you've used that. So you can create like things like pit-filled DEMs, drainage basin areas, flow direction. It's really powerful and it's great for hydrologic analysis. I would caution that it is very process intensive, so your jobs will slow down if you start selecting a lot of these products. So just be aware of that if you do choose that option. So then you just basically then put in a name for your job and click submit. And this is, again, where the magic of OT is happening. It's doing everything in the background. It's sort of going out to Amazon, subsetting that data set based on the bounds we selected, returning an LAZ, and then doing all of the gridding and raster creation in the background so that the user doesn't have to do it. So it's going through each step, and you could either wait and see this job produce, or you can just go do other things, wait for your email. When you click on your email link, it'll turn to a job like this. And what's nice, you could click on the duration and see actually how long each of these steps is taking. So here it's very fast because it's such a small area. It's querying in 3 seconds and then doing each of the steps in about 3 seconds. And I don't know if I mentioned it earlier, but if you are running jobs during this demo or shortly after, try and keep your jobs fairly small, maybe under 10 million points, because we have a lot of people on this webinar, and if everyone starts running huge jobs, it's really going to bog down the system and slow down everyone's jobs. So please be considerate of fellow webinar attendees. So again, here's the output that you get. You'd be able to download your raw point cloud, your derivative products, and here's that link to the poetry viewer that I mentioned earlier. So you would just open that up and you'd get into this poetry viewer to see the monument. There it is. One quick thing I'll mention if I have time is the My OpenTopo page. If you click on that, your 3-dep jobs will be listed there, and you could always go there and sort of select a job and resubmit by changing parameters. So it'll also keep a listing of all the jobs that you've run. So it's a nice catalog to see what you've done. So that is basically it. I guess, Chris, well, I'll turn it back over to you.
Sure. Thanks, Matt. I think you stop sharing, I'll take over. Just a couple more slides just in summary, and then we can answer any questions. So if you have questions, feel free to start dropping them in the Q&A, and we can work through them here in a couple of minutes. Sure. Okay, so now we're back. For me sharing my screen. So a couple of things that we want to just touch on here. So there is this restriction to access to these data, and I explained hopefully why that is the case and that we're working on trying to expand access more broadly. But I did want to remind people that just because you can't get the data from OpenTopography doesn't mean you can't get the data. The data are freely available, and there's lots of different great pathways into those data. One is the national map, which is the USGS's kind of geospatial data access pathway. So this is a screen grab from that interface, and you can see the polygons shown. And you can access tiles of point cloud data from here, as well as the underlying or the derivative products, the digital elevation models, the 1/9 arcsecond and 1 meter digital elevation models that are another piece of the national elevation data set that 3dep kind of underpins. You can also go directly to the Amazon data sets that we're accessing. So if, especially for somebody with a little bit of coding experience or comfortable with the command line, you can develop your own code using tools like PDAL to go directly to these buckets. And you could either hit the requester pays bucket and put your credit card in and pay for those egress costs. Or you can go to this public data set, which is where Amazon is basically providing free access to the data. And then you could spin up your own compute infrastructure in Amazon's cloud and process those data there. So this is really something I just want to make sure you're clear about. And then as Matt also mentioned, that Howard's group has developed this endpoint viewer that sits on top of that bucket. So it's the same interface Matt just showed you, but it allows you to grab any data set and view it in that Poetry web-based browser using those same tools. So there's a restriction on OpenTopography's value-added services to these data at the moment, but not a restriction to the data in access to everybody. So this is, I think, an important distinction. Another sort of just wrap-up topic is if you are somebody in the academic realm who's going to use, interested in using these data, or perhaps already are using these data, I just want to remind people about this remote sensing special issue. This is a volume that was put together by Jason Stoker, Tyson Swetnam at University of Arizona, and myself. We're the guest editors, and the idea here is to just capture interesting research that's based on 3D lidar data, or I guess IFSAR if you're working in Alaska. And so this is an open call at the moment. So if you have a paper or are planning to write a paper that might be appropriate here, we'd encourage you to submit. So that is essentially the last slide on this. We wanted to remind you that we've put together a feedback form on this webinar. Maybe Chelsea, can you paste that into the chat? So take a moment and click on that link and tell us what you think about the webinar, as well as OpenTopography. And then encourage you to, these are ways to interact with OpenTopography. So we have tried to be relatively active on social media, Twitter, Facebook, Instagram, etc. You can always email us via the info@OpenTopography email address, which goes to the team. I think that's it. So if there are other questions, please stick them in the Q&A and we can answer them. Let's see, we've got one question so far. So the question is, if my area of interest is vegetated, lots of forests and marshes, will 3Dep be able to distinguish the vegetation height and the ground surface? It's a good question. The answer there is probably, it depends a little bit on the characteristics of the LiDAR itself, what point density the data were collected at, specifications about the data collection geometry. Generally, LiDAR is pretty good at vegetation penetration, but certainly the number of points that are reflected from the ground surface are quite a bit lower than the overall total point density. So the total point density in the ground classification would be pretty low. If the ground is wet, say in a marsh environment, you may not get returns because most airborne LiDAR systems are near infrared lasers, which are not particularly effective at getting returns off of water. So it would depend, and I would say that you should, I would encourage you to just go explore. The nice thing about OpenTopo is it's pretty easy to go grab a piece of data from your area of interest and look at the DTM and look at the DSM and think about what you're seeing in the data. And you can also view the point cloud and filter by classification and really try to see what points are on the ground class. Any other questions?
Of course, we invite you to go and experiment with processing any of these data sets on our site, particularly do so now if you have any questions about processing or what the data look like, how to visualize it. We're happy to talk about that right now.
Yeah, or just general questions about OpenTopography that might be even not specifically 3D. This was actually a nice opportunity to just to remind people about what OpenTopo does, because I know some people haven't been into OpenTopography in a long time, and things have definitely changed in the last 3-5 years, whatever.
And I would also encourage people to, if they have any suggestions or things that they want to see in OpenTopo that isn't currently there, we'd love to hear back from you with regards to that as well.
Yeah.
I'll answer Zach's question. I see as Zach asked a question about if there are any plans for OpenTopo to host the 1/3 arcsecond MED data, and that actually is kind of on our list of to-do. It's on my list of to-do options. So hopefully that might be coming in the next weeks, months. That should be coming soon. So yes, there is plans to get that into OpenTopo.
Yeah, and that certainly in some ways addresses the computational issue, because right now we're computing DTMs and DSMs for every job, but if we just had those data sets sitting on disk, they're easier to deliver for sure. Yeah. And they reduce the compute overhead. So that's coming for sure. Okay, I got a couple other good questions here. So Mary, can you recommend a couple of examples? Can you maybe expand on what kinds of examples? Like examples of what, I guess?
So
the question in aerial
image that's showing up right now.
Oh.
We've made a number of news items, or Matt's made a number of news items that highlight several different key areas. So I can put in a link to one of these news items to browse some cool sites.
Yeah, definitely. And that's one of the cool things about this is it's really easy to go grab data and explore. And so I would encourage you to do that. But yeah, there's definitely a lot of nice images in the kind of news items that we've done. Matt makes a couple of cool images for every news item. Question about aerial extent. Can you estimate how large is too large for processing? So right now we're limiting to 250 million points per job. So that essentially impacts the spatial extent of a job as a function of the point density. So for example, if you want to grab all the points and like work with the vegetation included, so like a DSM type workflow, certainly that is a little bit more restrictive than if you want to work with only the ground points because it's a subset, so you can grab more area. The system will basically tell you your job is too large. And again, we're testing this. So for data sets that are hosted by OpenTopography, the red polygons on the map, the processing limits are a little bit higher right now if you request a power user account. And so we're just feeling out how this works and scales. It's been quite stable and performed quite well overall, although we have encountered a couple issues that we're trying to sort out.
The question, what is the timeline for the DEM differencing or topo differencing? So we've implemented this on data sets that are hosted by OpenTopography. And so this actually already captures a large range of geologic and anthropogenic processes. And we invite you to test the data sets or test the processing out. For those, it's about 50 data set pairs already. We don't have quite yet a timeline for adding the differencing to the USGS data sets.
Yeah, it's a work in progress, among lots of other things that are works in progress. Cool. Other comments. Mike Daniels asked about the background image that Matt and I are sitting in front of, I think. Yeah, that's White Sands, New Mexico data. And there's actually several airborne and LiDAR data sets, some of which were collected by NCOMS or NSF funded. And then I believe, Matt, this is an example from a USGS collect. So this is a really cool area, and you can use these topographic differencing tools that Chelsea has talked about to compute the difference. I showed a flickering thing on one of my slides of the White Sands migration. Maybe I can go back quickly and show people that. Let's see. Oops, got ahead of myself. This image right here on the left, the flickering, is basically 2 airborne LiDAR collections separated by roughly 1 year. And then the red-blue map is the topographic difference computed. So blue is accumulation of sediment and red is erosion of sediment. So you can see the wind direction from the southwest here pushing the White Sands dunes northeast. And it's really nicely illustrated here. And this is very simple to compute. All the graphics are generated by OpenTopography. We should do another webinar on topographic differencing, Chelsea.
Yes.
David had a question about the 3DEP data, if it has a minimum points per meter density. And Chris, you could correct me if I'm wrong, but I think most of the data is QL2 level and higher. Is that correct?
Correct. Yeah. USGS, I think the base spec to be included as a 3DEP data set is it has to be QL2, quality level 2, which is two pulses per square meter? 4 pulses.
4, yeah.
4, I think it's 4. There's a QL2, a QL1, and a QL0, basically. And they are increasing pulse densities. Good question. Let's see.
Chris, you know, there's a question about the White River image that we use a lot in OT. That was, do you know the background behind that image and how it was created?
Somebody at the Indiana Geological Survey produced that one from that's not 3DEP derived. That's from the 2011 to 2013 statewide Indiana collection, and they made that image. So it's on the White River, but I don't know specifically where.
Looks like we've had a couple of questions about bathymetric data sets. Chris or Matt, could you talk about any plans on that front?
The 3DEP, as far as I know right now, there's no bathymetry involved. But on that front, we actually are in the process of adding the SRTM plus data, which is a global bathymetric data set. not super high res, but it is data everywhere, which is really nice. And we also pipe through to the GMRT, which is run by Lamont, Columbia University, has a database of bathymetry, again, a global data set using shipping lanes and other things to get data, globally.
And so if you're interested in bathymetric data in particular, the NOAA has a site called the Digital Coasts, and which has a lot of LiDAR data that was collected for various purposes, some of which is like duplicate with the 3D data, but it also has a lot of topography and bathy nearshore LiDAR. And so that's another system that's out there that would allow you to get access to those data. So the Digital Coast is a good place to look. There are also within the NCALM data sets in OpenTopography, so data sets in red, some of those data were flown with a multi-channel laser scanner. So NCALM's most recent instrument that they're doing a lot of, they've been flying for the last several years now at least, has a 532 nanometer channel, which in theory is water penetrating. And so those data sets, you'd have to download them and filter them on your own, but there is a green channel in there that would be bathymetric in nature. If you've got more questions about that one or looking specifically for certain kinds of bathy data, maybe shoot us an email at info@topography.org, and Matt or I can steer you towards some of those data sets.
There's also, we need to plug ISAT too. So there's open altimetry that you can get through OpenTopography. There's a link on the Find Data map, and ISAT 2 has some pretty amazing bathymetry that you can use. So you can explore the data sets. If you go to the OpenTopography main, you'll see in the legend a link to open altimetry. I would encourage you to go to the ISAT 2 data collection.
Yeah, and actually, Vishu, maybe since you're out there, I see you manning the chat a little bit. Could you drop an open altimetry link in the chat? There it is. Done. Cool. Okay, other questions. Let's see.
For your LiDAR data on OpenTopography, which software website would you suggest to combine multiple point cloud data sets? Maybe give a little bit more detail about what you're interested in combining them. Is this for visualization or for differencing?
Yeah, it depends on your comfort level. I mean, from a command line perspective, PDAL and LastTools are really nice to use, and they're mostly free, at least LastTool. PDAL is certainly free. I like Global Mapper. I mean, ARC is always nice, but they have their proprietary sort of LiDAR formats. Global Mapper I find to be very powerful and a little more affordable from a commercial software perspective.
Yeah, I think that question has a little bit to do with, are you interested in merging point cloud data sets or raster data sets? And you might come at that a little bit different depending on which set of products you want to work with.
Yeah, there's also Cloud Compare, which is a nice tool, and I believe that's free as well.
Yes.
Yeah, Cloud Compare is very powerful for specifically for point cloud interactions and point cloud sort of merging and doing differencing and those kinds of things. Okay.
There's a question about the about a study. If I know a study area is subsiding 4 centimeters a year, I want to see the time series of DEM 10 years to check the changes. Is that possible in 3DEP, or only one value in time was provided? So I don't think that's possible. I mean, I think if we do the differencing, it's basically taking a snapshot between two times. I don't think you can get a time series currently.
Yeah, you would need topographic data that spans that same interval, and then it would have to be accurate enough to be able to resolve that sort of signal, that subsidence signal of 4 centimeters a year. So, there may be legacy topographic data sets that aren't LiDAR based in that region that you might be able to work with and use as a sort of pre-event timestamp that you can compare against a more recent LiDAR data set. But without knowing more about the specific data available in that spot, we'd have to be a little hard to say exactly what's possible. All right. Anybody else? No? Should we wrap up, Chelsea?
Sure.
Okay.
Thank you, everyone, for coming to our webinar today. I'd like, yes, to ask you to complete this webinar feedback form. And your free time, please follow OpenTopography on our social media channels. So that's Twitter, Facebook, Instagram. And if you have any questions going forward about OpenTopography in general or accessing the 3D datasets, we invite you to contact us at info@opentopography.org. So thank you very much for joining us today. We hope you have a good rest of the day.
Thanks, everybody.